Alright, I wanted to make a video on the mandrels I've been making and using. So what I've been doing is just making them out of wood because I got lots of it and it's cheap and easy, and if it doesn't work out, chuck it in the fireplace. So 260 big bore kit, 44.3 millimeters, and so I don't have a 44.3 millimeter mandrel yet, so I'm going to use the 42 just to kind of show you what I've been doing. And so I turned this to just a slip fit, so it'll just slide in there, and then I turn a relief on it so that you can work on the base when you go to trim it. And then, so this one I'm actually going to make a smaller mandrel on this side, and so I can do 2 saws with it. But anyway, clamp this in the 4-jaw chuck, and I use the center band to indicate it in, and then obviously the cylinder goes on that. And it's been close enough so far, because when this is running true and you're just taking a cut off the base, you don't have to be perfectly concentric. So that's what I've been doing for that. And I haven't made a face plate, I guess, where you can bolt these to it and reach into the boring bar and cut the squish band. And so just to tinker around with it, what I've been doing, and again, this is too small. So anyway, I just make a wooden mandrel, and then I take a piece of high-speed steel, and I just mill a slot in the end of it. And so this edge is on center, and then I just epoxy it in there, and then I'll grind the back of it. So I don't know if you can see that, but it's got a little bit of an angle. So it's got a cutting corner, and then I'll lap that in so it's just super sharp, and then just mill a little relief in there for the chips, give the chips some place to go. And so I can't do it on this one because it fits loose, but label it 44 millimeter cutting direction. And what I've been doing is just making a mandrel, and I use it to trim the base, and then I'll cut this into it too. So that's why I don't have another one right now, but anyway. So you can just turn this by hand, just go in and just rotate it, and it'll cut by hand. But it's nice to have one or the other stationary so that you can control how much pressure you're putting on it and start and stop smoothly. Otherwise you kind of wind up with divots in the squish band. And those are casting marks in this one, but it kind of looks about the same if you're getting divots in it. And then you got to try a little bit harder to smooth those out. But so anyway, this is another one. So that one, this one cuts to the right, this one cuts to the left. And so I don't know if it makes any difference. I just tried the other way. And so this one, you can see, I actually slotted that just to minimize any friction, and then lap the top of it. And this one works really good. This is for a 660. And so the other thing I've been doing here is trying to get these pistons in a 4-jaw chuck is a pain in the butt. And so this is a 42 millimeter piston, and I don't have a cup made for a 42, but you get the idea here. So I center a block in the lathe, and then you make it this way. And so I face it off, cut this diameter, leave a shoulder, cut that, and then flip it over and use this shoulder to indicate it in so it's pretty close to concentric. And then I'll bore this out to the size that you want, and you just want to slip fit. And then this was just a trial. I just made a quick cut right here and stick the piston in there. And then when you squeeze this down in the chuck, it squeezes the piston and it keeps it centered. And then you can move it in and out. You know, I like it about there, so you have some working room. But if you're just doing a dome or something, you can stick it in all the way in there, and that squeezes it and keeps it centered. And then you can actually dial your piston in so it's perfectly concentric. And this shoulder keeps it from being pushed further back into the jaws, and then your piston is stationary and centered, and it's not going to slip, and you don't have to worry about damaging the skirts with the jaws and trying to protect them and the whole thing. I've tried tape, I've tried it all, and so this works really good for me. And again, wood is cheap and easy and disposable, and so yeah, so anyway, as I go through more and more saws, I'll just have a cup for each size, mandrel for each size, I guess a standard mandrel, and then I'll have a cutting mandrel, and have a whole collection. But I'm in Montana where it's pretty dry summer and winter, especially summer, but in other parts of the country, wood may not work. You know, if you got humidity, high humidity, might cause issues. But I've found that once I bring the wood into the shop and let it sit for a week or so, it kind of acclimates to the shop, and then I don't have any issues with expansion and contraction of the wood. And this is oak, and I've got a couple others made out of, I think, yew and ironwood. And so I try to use a hard, dense wood just for wood movement, both in flex in the lathe, but also just environmental expansion and contraction and whatnot. So anyway, that's how I've been doing it. It might seem a little bit backwoods, but it's just kind of a hobby right now. So I'm not doing thousands of saws where I got to have precise mandrels and whatnot. So anyway, that's one way to, you know, get pretty good quality work and not have thousands invested into tooling. So anyway, hope it helps.